Dear students, let us start the new topic of the third module. In this video, we are going to study the symbolic link file API, the environment of a Unix process, introduction, main function, and process termination. So let us see the symbolic link file API. What is a symbolic link? A symbolic link is an indirect pointer to a file. As I said in the previous video, that if a file is created, a different name of the same file, Unix can maintain the different name of the same file, and those names will point to the same file. So that is called the symbolic link. So a symbolic link is an indirect pointer to a file. This link points to a file, original file, with different names. Symbolic links can link files across file system. Means using the symbolic link, we can link from one directory to another directory. Symbolic links can link directory files. Symbolic link can also link the directory files. Symbolic links are typically used to move a file or an entire directory hierarchy to some other location on a system. So as you know that in Unix all the files are arranged in hierarchy way. So using the symbolic links we can move or we can shift the files from one place to one location to another location. A symbolic link is created with the symlink, SYMLINK. So let us see the prototype. So integer symlink const char star original underscore link comma const char star sim underscore link. So here original link, it gives the original file name, and symlink it gives the new file name with which we want to create the symbolic link. Similarly, we can have a read link. So const char star sim link char star buffer and integer size. We want to read from the symbolic link file. So first argument is the symbolic link, which points to the original file, and buffer. Buffer means it stores how many bytes it want to read, and then size. Then L stat const char star symbolic link struct stat star stat v. This is also the supporting prototype for the symbolic link. Let us see one example program. Hash include unistd.h hash include sys. This program illustrates how to create a symbolic link. So integer main, integer argument c, char star argument v. So we are creating a buffer, char buffer pointer, char star buffer 256, and another pointer t name 256. Now here for using that command line argument, we are going to pass the 4 arguments. So if argument c equal to 4, then return symbolic link argument 2 and argument 3. Else, so argument 2 will work as a original file, and argument v3 will work as a symbolic file. So symbolic file will be created here. Else return argument v1 argument v2. Otherwise a hard link will be created. Next topic which we are going to study is the environment of Unix process. In this one introduction we are having a process is a program under execution in a Unix or POSIX system. What is a process? When a program executes or a running status of a program is called the process. That's what it is telling. A process is a program under execution in a Unix or POSIX system. Then main function. Here we have a C program starts execution with a main function. So a main function, how it can be written? It can be written like that: integer main, integer argument C, and char star argument V. Where argument C is nothing but it is the number of command line arguments we are passing through the command line, and argument V, it is an array of pointers to the argument. Argument V is an array of pointers to the argument. So when a C program is executed by the kernel by one of the execute functions, a special startup routine is called before the main function is called. So C program is executed by the kernel by one of the execute functions, a special startup routine is called before the main function. So through the kernel, startup routines will be called before the main function is called. The executable program file specifies this routine as the starting address for the program. So this program which you have written the main function. So that program specify the startup routine as the starting address, and this startup routine takes values from the kernel. So this startup routine take the necessary values from the kernel, the command line arguments and environment, and sets things up so that main function is called. So the command line arguments it takes, and the environments will be set up so that main function is called. So it's a very simple. When a program in a program, suppose main function is there, so every program starts from the main function, but before main function starts, that kernel will start a startup routine. So a startup routine, what it will do, that it takes the address. Startup routine will be considered as the starting address of the executable program, and startup routine takes the necessary values from the kernel, command line arguments it takes, and then it also takes all the environment variables. It sets the things up so that the main function gets executed. Next topic which we have is the process termination. So there are 8 ways a process can be terminated. When a process is running, finished its execution. After execution, it wants to terminate. So how many different ways we can terminate a process? So there are 8 ways we can terminate. A process. So there are 5 ways using which normally process can get terminated in 5 ways in normal condition. So those 5 ways are: first, return from main function. Main function, everything gets executed, and from main function it is returned. Then calling exit, call underscore exit, and or underscore uppercase exit. Then fourth is return of the last thread from its start routine. Fifth,